Now I want to start with one part related to calculation electric fields. And just I will say here, if I have a single charge, then I can say E equals K Q over R squared. And K, it is a constant that we call it, K, and it equals 1 over 4 pi epsilon 0. Epsilon 0, we call it the electric constant, and it is 8.85 10 to the negative 12 coulomb squared per Newton meter squared. K equals 1 over 4 pi epsilon 0, and it's always easier to, have K ready for the calculation using 9 10 to the 9. Now, what about the direction? If we have a positive charge, then the electric field is going to be, direction is going to be away from the positive charge. And if it is negative, it's going to be towards the negative charge. Now, what about if I have a distribution of discrete charges? Then I'm going to have a plus, a negative, a plus here. And we want to find what is really the electric field at this point here, P. And therefore, I will say we're going to first calculate the value of E1, and that is going to be K Q1 divided by R1 squared. And we're going to find also the magnitude of E2 by saying it is K K2 over R2 squared. And then finally, E3 is going to be K Q3 over R3 squared. Since the electric field is a vector quantity, then we need to determine the directions of E1, E2, and E3. And here I did show you. Now for Q1, it is positive, then the field should be away, okay, E1. And for Q3, it is also away, then it is to the left. And E2, it is, since the Q2 is negative, it's going to be in this direction. Now I can add the fields as vectors, and therefore I need to split E2 into two components, E2 cosine theta and E2 sine theta. E2 cosine theta is along the x-axis, and E2 sine theta along the y-axis. And then I can work on the Rx. It is E2 cosine theta minus E3. And Ry, it is E2 sine theta minus E1. And here I will calculate, this is the magnitude, and this is the direction. This is the principle of superposition, which I want you to review so that you will be able to calculate the values. Thank you.